Hi, welcome to the videos on Virtual Lab, which is developed at Department of Telecommunication Engineering at SIT HWR. So let us demonstrate how do we access the Virtual Lab, which is available at the Department of Telecommunication. As it was mentioned in the mail and the messages that is forwarded to you, so you're supposed to have an internet connection and the system what you're using should have a team viewer. So let us assume that this is the team what you're installed TeamViewer tool. So upon clicking on that TeamViewer tool, we are supposed to enter the partner ID which is being provided when you actually register for Virtual Lab at SIT. So assume that this is the ID that has been provided. Now you are asked to connect to the partner. Now okay, we are connecting to the partner. It will ask for the password. So let me give the password. So upon giving the password, and now I have entered the given password. Now let me say login. So when it is logged on, now it will be connecting that server is there in telecommunication department lab. Now it is now connected to now the screen of that particular system has been shared to you. Now this is the main window do the virtual app. Now this is okay, let us go to home. This is SIT Institute of Technology Tumkur Department of Telecommunication Virtual Lab. Now you are welcome. Now you are supposed to click on this to start. So this is the virtual lab for analog electronic circuits. Click for experiments on rectifier circuits with line and load regulation. So let us proceed with this. So if I click on this, I'll move on to the available circuits. The first circuit what we have is the half-wave rectifier and regulator. So let us click on this half-wave rectifier and regulator. I'll click on this. Now let me just minimize theme. Now I want to do half-wave rectifier circuit. Now before we actually start conducting the experiment, so let us see what are the experimental detail that we have for this particular experiment. If I click on this, I'll get the details of K diagram, what are components that have been used. As we can see here, we have a center tap transformer with rating 909. So there is a diode 1N4148 and a resistor of 1 kilo ohm with 1 watt is connected. Now the input applied voltage is 230 volt 50 hertz for the transformer. Now we have the design, the peak voltage for a 909 center tap transformer happens to be 25.4 volt with VRMS as 18 volts. As we can see now, we have connected the output of the secondary of the transformer are 9 and 9. So the RMS voltage happens to be 18. Corresponding peak voltage happens to be 25.4. As per the equations, we know that half a rectifier will have a DC voltage V peak by pi, which happens to be 8.1, and we know that we are supposed to get a output voltage of nature. Now the white one corresponds to the input, the blue one corresponds to the output. So that can be seen by connecting two channel output voltage, that is C1 at the input and C2 at the output. So let us see how do we connect this C1, C2 using going to measure these values. These are the calculated values to measure the voltages. Before you proceed with any of the experiment, we are supposed to close this images. So that's a must for continuation of the experiment. For the development of virtual lab at SIT, we have used National Instruments, one of the product, that is analog discovery. Analog discovery is the one which is extensively used in this virtual lab to measure the voltages at different nodes. So let us try to find out, okay, how do we use that analog discovery and how do we actually measure it. So as we can see, there is waveform 2015. We have to click on this. So this is waveform 2015 is the one which will going to. So let me minimize this. So I'll click on Now, as it was said that the unlock discovery waveform is used in this virtual lab to measure the voltages at different nodes. So let us see how do we utilize this unlock discovery waveform. Let me click on this unlock discovery. So now let me just see. Now the unlock discovery has an oscilloscope. It has got a waveform generator. It has got a power supply. It has got meter. It has got a logic analyzer. It has got a pattern generator. It has got a static IOs, and it has a network analyzer. It has a spectrum analyzer also, and it can you can actually see the scripts. So these are the capabilities of the unlock discovery. But for this particular virtual lab experiments that is developed here, we are only using the scope option of this unlock discovery. So let us click on this scope. Now you can see this is the window where we can see the two oscilloscope channels, that is C1 and C2. As we can see now, C1 is in yellow color, C2 is in blue color. If I say run, it will actually voltage at what is at channel 1 and channel 2. If you can actually see the circuit diagram what we have observed the previous circuit diagram. So as you can see now, there is a C2 plus. The channel 1 is connected the input of the rectifier, 2 is connected the output of the rectifier. Actually see waveform F1 corresponds to input, C2 corresponds to output. But we are not getting anything now because we have not yet conducted the element. So let me slightly rearrange the windows and then try to properly. Okay, we have to see input voltage which is sine wave and the output voltage should be a half a rectified signal. So let us go back to the stored waveform and try to get the same thing. As we know that the input frequency of the signal is 50 Hertz, we are supposed to adjust this phase here now. So that is time base, which is 1 millisecond per division. So let me make that time as something like, now the time base has been changed. Now let me just see what is the output waveform. Now the time base has been changed. Let me also change this volts per division to 15 volt per division, and let me change this also to 15 volt per division. Now what I will again conduct the experiment. So what I'll do is I'll restart the experiment, and so that I can be able to get the proper waveform. Now I'm seeing both the front panel of the unlock discovery as well as the oscilloscope channel of the unlock discovery. Let me run it now. So if I run, this will go off because I have to the experiment. If I start now, you can see I'm getting the. So now let me get waveform so that it can store the values. Now we can actually play with this oscilloscope to actually measure the voltages at different points. Now as we know that the circuit what we are looking at is this. So let me just put this. We are looking at the like this. So that what is the peak voltage. So okay, let me just go to only that half a rectifier experiment. This is not. Let me go back to the half a rectifier. This is what we are supposed to measure. We are supposed to measure what is the RMS voltage. We are supposed to measure the peak voltage. We are supposed to measure the VDC, and we are supposed to measure VD on also. So let me minimize this and measure the values using the unlock discovery waveform. Suppose actually see now. So let me just IP. Now how do I actually make the measurement? To make a measurement, you can go to this view. Okay, just make this bold. Now you can actually measure the values. Now go to this view. There is a measure option where you can add the parameters. Go to this add defined measurements. I'm defining some measurements. In channel 1, I want to measure a vertical parameter. One is the RMS voltage. Let me measure the AC RMS, which happens to be 18 volt. And in channel 2, okay, let me also measure in channel 1 the peak voltage, that is maximum. You go to this channel 2, you measure the maximum. If you double click on that maximum, that value will be get added onto the list. Now in channel 2, I want to measure the average voltage. So let me measure the average voltage here. So this is the average voltage. Let me close. Now you can see these are the voltages that we are trying to measure. One is AC RMS voltage, which is the input applied voltage, and other one is the peak voltage of the input voltage, which is 25.17, and the peak voltage of the output is 24.4. You can certainly see there is a difference of almost 0.7 volts. This is actually the VD on, and the average voltage, the DC voltage of the output voltage is 8.129 volts. So let us go back to the schematic this and then try to find out. So let us try to edit the values. We actually supposed to have 18 volt, which is 909. I'm getting exactly 18. This is actually the measured voltage. This is the calculated voltage. I can edit this as 18.00. You come down to this. The peak voltage is actually 25.17 of the input, but theoretically it would have been to 25.4. This is the theoretical value, and this is 25.1, and you can actually note is the DC voltage, which is here, which is 8.1. Type it as 8.1. These are the actually measured values. Now we can see the calculated value is 18 volts, and we could also get almost exactly 18 volt. The maximum voltage was supposed to be 25.4 as per calculation, that is root 2 times PRMS. We get whatever that we are measuring here is the practical values which is there running at SIT Tumkur, and I'm sitting at a different place. I'm trying to measure it using my system, and the measuring is 8.1, and I'm supposed to get 8.1. Surprise is the same. And I can also measure is the VD on. VD on happens to be 0.7, that is the diode drop, which is the difference of the maximum of the input and maximum of the output, which is 25.1 minus 24.4, which happens to be almost 0.7 volt. So these are voltages what I'm trying to what I'm measuring. So from the actual experiment which I did virtually. So I'm not going to SIT, but still I could able to measure the voltages because I could able to connect the experiment remotely. Okay, we could able to do the experiment now. If I run this, it will go off because by this time the circuit would have been. Now let me go back to previous. Let me do a half-wave rectifier with C filter. Half-wave rectifier C filter. So let us have what the circuit diagram experimental detail says. So experimental detail says that you have a diode, a resistor, and a capacitor, and we know that we are supposed to get some ripple voltage. As we can see now, capacitor charges and discharges, charges and discharges. We are again going to have a RMS voltage of 18 volts. The peak voltage is 25.38, and the ripple voltage as per this equation happens to be 4.93 volt if you are connecting a capacitor of 100 microfarad. If the capacitor connected is 470 microfarad, it will be 1.05 volt. So let's go back to circuit and then conduct the experiment and try to measure what is the voltages. So let me click on this. Now you can start conducting the experiment. Let me click on this. Now you can see we get the waveform. So this is exactly the way how it was in the experimental detail. Let me stop on this and try to measure what are the voltages. Now you can see I have the maximum, I have the average of C2. So I'm not interested in the average voltage of C2. I'm interested in what is the peak to peak voltage of C2 that can be easily measured. Go to this add, defined measurements, select second channel, select vertical, double click on that, see what is the peak to peak voltage. Peak to peak voltage is now 4.23 volt. Theoretically also, or as per calculation also, it was the same. So this way we can able to find out what is the peak to peak voltage for